Okay. So balance the least repeating element first. This is the first rule, that least repeating element should be balanced first. And second is that if you are going to balance the element, just uh, balance that element first or at last, which is found in its molecular or elementary form. Like for example, oxygen is found in its elementary form, nitrogen is found in its elementary form, oxygen is found, I2 is found, Br2, I2, Na, Mg, S. Okay, so these are found in its elementary form. Okay, so you are not going to balance that element first. Okay, you will balance that element at last. If an element is found in its elementary form, like for example here in the next equation, like I'm going to show you here, like for example oxygen is written here alone. So if the oxygen is written alone, then it means that you are going to balance that element at the last. Okay, so if some element is written in the last, and then you will in its elementary form, then you are going to balance that element in the last. Okay, so write down these 2 points for, then I'm going to explain you what I'm saying here clearly. So write down these 2 points: rules for balancing the chemical equations. The rules for balancing the chemical equations. When you're done, please let me know.
Sir,
Yes,
sir, for the heat, can we use also like make the triangle symbol here?
speak a little bit louder. What you said? Just wait a minute. Let me plug in that phone. Just wait a minute. Now say what you saying. Speak.
Yes, sir, I'm saying that for the heat symbol, can we also like make a triangle?
Yeah, but triangle is generally written as in chemistry we write triangle as change. So here the heat symbol is not, we don't write it like this way, but change, this triangle symbol represent the enthalpy. Okay, enthalpy, or we can change in something. Okay, so it is better to write heat. You done? Noted?
Yes, sir.
Everyone? Arya and Nabila, you also?
Yes, sir.
Yes, sir.
So if I give you a simple equation that like for example, if I'm writing here S3 S3 PO3, when heated, it will gives you S3 PO4 plus PS3. Which element you are going to balance here?
Sir, H3.
H. No, H is multiple time repeating.
P.
P is
Oh,
also 3 times repeating.
oxygen.
Oxygen you are going to balance first. So you will take note that how many oxygen atoms are there? 4. And how many are there? 3.
3.
Okay, so you have to multiply by what number you should multiply this 4 and this 3 so that they both will become equal.
3 should be with 4 and 4 should be with 3.
Yeah, so you have to multiply here by 4 and multiply this one by 3. Okay, you can only try this trigonometric coefficient, means you can write the number here, you cannot interchange here. Okay, got it? So now this 4 is not only going to multiply with this oxygen, it is also going to multiply with this phosphorus as well as oxygen. Okay, so can you tell me that this is the oxygen here? Got it?
Yes, sir.
Now count the total number. Check whether the hydrogen is balanced or not. Check the count. Check the Yes. Check the number of hydrogens on the left hand side, on the reactant side.
The 12. Uh,
12. Yes, it is 4 into 3. It is 12. Hydrogen is 12 here. And here check whether it is balanced or not.
yes, sir, it is also 12.
It is also 12. How? 3 3 is the 9 and 3 12. Okay. Now check the number of phosphorus. Check the phosphorus. How many phosphorus atoms are there? 4. And how
Yes,
many are
sir.
there? 3 plus 1, 4. Okay. And oxygen is also balanced. 4 3 is 12. 3 3 3 4 is 12. Okay. Balanced. So this equation is balanced. Okay. Note the next one. Do the next one. Note it down first. And then when you're done, please let me know. You done this one? Balance this
Yes,
Yes.
one.
sir.
FeSO4 when heated, it will give you Fe2O3 plus sulfur dioxide plus sulfur trioxide. Try to balance this equation.
Sir, we will do the balance like first oxygen.
Why oxygen is multiple time repeating? Why are you going to balance oxygen first?
So we will write 2 FeSO4, then gives you the 2.
Which element first? Tell me that which element you are going to balance first.
Sir,
Yes.
we can do like Fe.
Yeah. Fe is single time repeating. Sulfur is repeating 2 times. Oxygen is
Yes.
repeating 3 times. Only Fe is repeating once. Okay. So here, how many Fe are there? 2. And how many Fe are there? 1. So you just multiply this one by 2. Now check whether the elements are balanced or not.
Sir, the Fe is balanced, but like SO4, we have to balance it again.
No, no, no. Check how many sulfurs are there.
So it's balanced.
It is balanced. How many sulfur are there? 2. How many sulfur are there? 1 and 1, 2. How many oxygens are there? 2 4s are 8. How many are there? 3 plus 2 plus 3, 8. Okay, so it is balanced.
Yes, sir.
Yes, sir.
Okay, try to balance this one. PbNO3 whole twice when heated, it will gives you PbO plus NO2 plus O2. Try to balance this one. You done? Try to balance it.
Yes, sir, it is done. Sir, will get the answer.
What's your answer? What's your answer?
Yes, sir, it is like 2 PbNO3, then bracket 2 gives you 2 PbO plus 3 NO2 plus O2.
2 here, 2 here, 3 here, and then
sir, uh,
here it is something or not?
no, sir.
How many nitrogen are there? 3. And how many are there? 6. Sorry, how many are there? That is 4. According to this, because one PbNO3 has 2 nitrogens. So there are 2 PbNO3. So there will be 4 nitrogens. There will be 4 nitrogens.
Nitrogen.
So this is 3 nitrogen. It is incorrect. So let's you first tell me that which elements you are going to balance first. Yes, Nabila, tell me which elements you are going to balance first here.
Pb.
Pb, because Pb is Pb you can balance, or nitrogen you can balance, because it is single time repeating, and we are not going to balance oxygen first because it is multiple time repeating. Moreover, it is found in its elementary form here. So we are not going to balance that one first. Okay. You understood?
Yes, sir.
So here you will write what you are going to write here. 1 pp, there is 1 pp, there is 1 pp. This NO3, it is 2 is multiplying with N and O only. Okay. N and O only. So you have to multiply this by 2. You understood? Sorry, you don't need to multiply it by any number. Okay, because that is already balanced. Now coming to the nitrogen. Next least repeating element is nitrogen. So how many nitrogen atoms are there? 2. And how many are there?
1.
1. So you have to multiply it by 2. You just multiply
Yes.
by 2. Nitrogen is balanced. Now coming to the oxygens. Now it's a time to balance because that is already balanced. Now coming to the point here is nitrogens. How can you balance the oxygen first? You check here, that is 6 oxygen. How many oxygen atoms are there? 1 plus 2 to the 4 and 2. Total, in total, how many it is? 7? 7. If I write any number here, then lead will again unbalance. If I write any number here, then nitrogen will along unbalance in order to balance the oxygen. So just come to this oxygen. If this oxygen instead of 2, if it is 1 oxygen, then it will be balanced.
Yes,
1 plus
sir.
4. But
Yeah.
you can't write O2 as O. It is not the rule because it does not found in the atmospheric form. It does not found in the form of O. So we have to write it 2. So how can you make 2 1? By what number you should multiply 2 to make it 1? It can be a fraction also. Tell me the number by which you are going to multiply 2 so that it can become 1. It would be
1 by
half.
2.
Yeah, simple half. Just multiplied by half. Okay. Now legally this equation is balanced. This equation is balanced. No one is going to say that this equation is not balanced. This is balanced. But it looks odd when you write 2 in the denominator. Okay, half O2. So in order to balance this O2, we are just going to multiply this whole equation, left hand side as well as right hand side, with this denominator that is here too. So when you multiply this equation by 2, you will get 2 PbNO3 whole twice. Okay, Harshit, you got it? When you
Yes, sir.
multiply this number by 2, you will get 2 PbO.
PBU.
When you multiply this number by 2, you will get 4NO2.
Yes,
When you
yes.
multiply this one, what you will get? You will get only half. Half means half O2 multiplied by 2, you will get cancelled. You write 1 O2 or you write O2 only. Okay, now this equation is balanced. You can check that, you can check here that 1 PbNO3 has 2 nitrogen. 1 PbNO3 has 2 nitrogen. PbNO3 whole twice has 2 nitrogens. So the 2 PbNO3 will have 4. So this is 4
Yes.
nitrogen. There is 2 lead. 1 PbNO3 has 6 nitrogen. So 2 PbNO3 will have 12 oxygen. Sorry, 1 PbNO3 has 6 oxygen. 1 PbNO3 has 6 oxygen. So tell me fast. Tell me fast. 1 PbNO3 has 6 oxygen. So the 2 will have 12. So here is 12 oxygen. How? First, you will multiply 3 to the 6, and 6 is going to multiply with 2, you will get 12. So you can check here, 2 oxygen, 8 oxygen, and 2. You balance, it is balanced. Is it balanced
Yes.
or not?
Yes.
So here, you can check it. You noted, everybody?
Sir, I have to ask
Yes,
you.
sir.
Yes, yes, ask.
So like in this equation is like only one element is also my wrong. So will I get marks or not?
If you write in the fraction form, up to here,
Next, yes, sir, like only one.
one element is unbalanced. No,
Yes,
it
sir.
will it
So
will not be, no, you will not get marks. For balancing the chemical equation, you will not get marks. You have to balance it properly, na? Otherwise it is unbalanced. So coming to the point here is that if you let's you try this equation, C plus C2S6, 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 when multiplied with 1 in oxygen, in the presence of oxygen, it will give you CO2 plus water. Try to balance this one, please.
Done, sir.
done, sir.
Done?
Yes,
Yes.
sir.
Okay. So what's here? Tell me how you balance this one.
So it's C2H6 plus 2O2 gives you 2 CO2 plus 3H2O.
2 CO2 plus 3 H2O. I know. How many number of oxygen?
Sir,
Yes,
in the reactant side, shouldn't it be 9O2?
9 O2. So if you write 9 O2, it will be 18 O2. And here you check
Yeah.
it. How many are there? 4 and 3, 7.
Oh. Mm.
So how will you balance?
Wait, let me do again.
Nabila, you did this one?
No, sir.
Try it once. Try it once more.
Okay, sir.
Balance that element first, which is least repeating. So either you balance the carbon or hydrogen. Don't balance the oxygen because oxygen is multiple time repeating. And although it is written in its elementary form.
So my answer is correct or not?
Your answer is also incorrect. Try to balance it.
Sir, I got
C2H6 plus 6O2, which is 2CO2 plus 3H2O.
You got 3 here. Okay, let is no
6O2 in reactant
6
side.
6O2, and here
Yeah. 2CO2,
and here.
3H2O.
So it is 7 oxygen total. Here is 12.
Mm. Oh,
Okay, let's try. What by what number you are going to multiply this? You will get 2 carbon here. You will get 2. So you multiplied by 2, 2 CO2.
yeah.
You get here 3, and you need to make it how much? How much?
6.
6. So you have to multiply by 3. Harshit, you understood this one?
Yes, sir.
Now what you are going to do here? You find here that here is total 7 oxygen. 4 here and 3 here. Total is 7. Now 7, how can you make this 2 by 7? By what number you are going to multiply this 2 so that it can become 7? It should be 7 by 2. Required, whatever you required upon whatever it is given. RG, other thing. Okay. So you have to multiply to 7 by 2. This 2 will cancel out. Now it is legally balanced. Okay. Again, you have to multiply this whole equation by 2 so that this 2 will cancel out. So you'll get 2C2S6. Now this 7 by 2, when going to multiply this one, you will get 7 by 2 multiplied by 2. This will cancel out. So you will get only 7O2 here. Okay. And then this 2, when multiplied with this one, you will get 4CO2. And this 2, when multiplied with this 3, you will get how much? 6H2. Now check whether it is balanced or not. Check it. How many hydrogens are there? 12. How many are there? 12. How many carbon are there? 2 to the 4. How many are there? 4. How many oxygen are there? 14. How many are there? 4 to the 8 and 6 1 the 6. 8 and 6, 14. Is it balanced now?
Yes, sir.
Do it. Copy it, please. Try to balance this equation. C2H5OH. When react with O2, it will gives you You done? Tell me
One
you
Yes,
done
minute,
sir.
sir.
this? Doing?
Yes, sir, done.
Okay. What number you write here?
Sir, like it will be like C2H5OH plus 2O2 gives you 2CO2 plus 5H2O.
2O2 plus then
Uh,
2CO2 then 5H2O.
yes,
Here is 10 hydrogens. Here is 6 hydrogens. Total 5 plus 1, 6. Here is 2 to the 4 and 1, 5 hydrogen oxygen. Here is 4 and 4 and 5, 9 hydrogens oxygen. Sorry. Balance it again. Balance it again, please. Nabila, you done this one?
No, sir.
Are you trying?
Yes, sir.
It's very simple. Why are you taking so much time? It's very simple. Are you done?
sir, sir,
No,
it will be like
sir.
What's
I'm
the answer,
still
Arya?
doing.
Still doing. And you? Yes, Harshit.
sir 2CO2 H5O H plus O2 gives you 2CO2 plus 5H2.
How much? What's the number here?
So when
Before O.
sir, I no sir, there is no number.
No number.
Yes, sir.
And what is the number here?
Sir,
2.
2. Yes, sir.
And here?
5.
You were just saying this was the previous number there. 5, 1
No,
the
sir.
5. Just count the total number of oxygen, whether it is balanced or not. There are only 3 oxygen. 1 here and 2 here. 3. And only the 5 is with there. 4 plus 5, 9 oxygens are there. How it is balanced? Try it. This is very simple. It is really very easy, sir. Okay, try it. Which element will you balance first? Tell me fast. Which element you are going to balance first?
See, sir, in front of O2, it is 3.
Yeah, it is 3. It is balanced. Now you have to balance oxygen carbon first or hydrogen first because it is not multiple time repeating. So this balance carbon, how many carbons are there? 2 is multiplied by 2. How many hydrogens are there? There are total 6 hydrogen. 5 here. Okay.
Yes, sir.
5 here and 1 here. 5 and 1, 6. And here are how much? H2O. 6. So you have to multiply by 3. 3 to the 6. 5 and 1, 6. Okay. Now It's time for the oxygen. How many oxygen are there? 4 and 3, 7. Total 7 oxygen. 4 here in carbon dioxide and 3 here in water. Total 7. 1 is already present here. So how much are remaining? 1 is here. So if I write is 6, 1 plus 6, 7. So make it 6 by multiplying by 2. We'll get 6. Understood now?
Yes, sir.
Okay, let's check whether you can be able to do the next one. Try to balance this one. Na, NaOH plus Fe, Fe2SO4 whole thrice. It gives you FeOH whole thrice plus Na2SO4. Just treat when there is no decomposition of sulfate ion is taking place, like here is SO4 and here is also SO4. Just consider SO4 as one quantity. Like you consider here how many SO4 are there? There are one SO4. And how many are there? There are three SO4. Here is 3. Okay. Like how many OH are there? 1. And how many OH are there? 3. So just completely if it is not means if it is not decomposing, like in the previous one, FeSO4 when heated it will gives you Fe2O3 plus sulfur dioxide plus sulfur trioxide. So here the decomposition of Fe2O3 is taking place. Here the decomposition of Fe2O3 is taking place. Sorry, sulfate ion is taking place. This sulfate ion decomposes into sulfur dioxide, sulfur trioxide. But here the decomposition is not taking place. This is attached with Na and this is attached with this one. So you will treat in such type of equation in which the exchange of ion is taking place. Just treat the polyatomic ion as a whole as a single entity. Okay. So you can consider like here that how many sulfate ion are there? 3. And how many are there? 1. How many OH ion are there? 3. How many are there? 1. So you can treat it like this way. Okay. Now try to balance this one.
So I think I got it.
Okay, Arya, what's your answer?
In the reactant side, in front of NaOH, 3 will be there, and in product side, in front of Na2SO4. Oh wait, it's Na2SO4. Never mind. Never mind. So
Oh no, it's okay. It's okay. Vita. It's okay.
Done, sir.
You are learning. You are learning. Okay. You are not.
Sir, correct.
How can you be perfect in the first class? Yes. Yes, you Harshit done?
Yes, sir.
What's the answer?
Set 2NaOH plus Fe2SO4 practically
Just
gives you
just wait. 2NaOH. Okay. Then
Fe2SO4, then practically same
Fe2SO4. Fe2SO4.
SO
Here is any number or not? No number? Here? Is there any number or not here?
not sir.
Here?
Yes, sir, 2Fe.
Here?
No, sir.
What's the number here?
Sir, no.
No number. So how the sulfate ion are balanced? Here is 3 sulfate ion, here is only 1 sulfate ion. Nabila, your voice is not coming. Are you trying with her?
Yes, sir.
Just try it. Okay, I'm just going to give you a hint. Here will be 6. Okay, find out the other values. It's very easy now for you. I'm just going to give you hint. NaOH will be 6.
So, sir, there will be like 3Na2SO4 in the product side.
It will be 3 here. You're
Uh,
saying?
yes, yes,
Yes, 3 to the 6 Na and 3 SO4 is balanced. Okay.
yes.
And here is 6 OH ion. And how many are there? 3 only. So just multiply it by 2. It will be 2Fe, 2Fe, 6OH, 6OH. Okay. So you can balance like this way. Okay.
Yes.
But I have helped
Yes.
you here. I have helped you here. Then how I get the 6? First, I'm going to explain you this one. Okay. Let me explain. First, you will balance the polyatomic ion. Okay. How many polyatomic ion there are there? OH is 3. Just and there is only single OH, just multiplied by 3. Okay. OH is balanced. How many sulfate ion are there? 3. And how many are there? How many are there? 1. Okay. So you have to multiply by 3. Now the sulfate ion and OH ions are balanced. Now, how many sodium has become here?
6.
6. Okay. It is 6. And how many I have written here? 3. So according to this, I should multiply this one by 2. Okay. Okay. Is that clear? Now the OH ion has again become 6.
Yes.
6. Now you have to multiply it by 3 to balance. This 3 is here is 3. You have to multiply it by 2 so that it will become also 6. So when you keep on practicing this question, this type of question, then you will be able to perform the answer. Okay. Okay.
Okay, sir.
Yes.
So 3 to the 6. Okay, let's move to the next type of part, that is exothermic and endothermic reactions. Okay, the reaction in which energy is supplied, such type of reactions are called endothermic reactions. Means on the basis of the energy released during the reaction, we have divided the chemical equations into broadly 2 categories: exothermic reaction and endothermic reactions. Okay, exothermic and endothermic reaction. So note it down: type of reaction, exothermic and endothermic reaction. Types of reaction: exothermic reaction and endothermic reactions. What is exothermic reaction? Exo means the word exo come from the exit. Exit means that heat is evolved, energy is evolved. So the reaction in which energy or heat is released during the reaction is considered to be as exothermic reactions. Okay, got it? Note it down. You done? Noted.
Yes, sir.
Now, sometimes we will simply say that, for example, how a chemical reactions takes place. Let me just explain you here. Like, for example, this is the hydrogen. Okay, the two hydrogen atoms. Here is two hydrogen atoms. Okay, and these two hydrogen atoms are combining together, and this is the oxygen atom. They are just combining, and making they are making bonds. So what is going to happen here? That these two hydrogen atom and these two hydrogen atoms are combined, are broken. The bond between two oxygen atoms are broken, and they are now forming the new bonds. Okay. So when a bond is broken, the energy is supplied. Always, it is a rule. When you are breaking a bond, the energy is supplied. And when the new bonds are formed, the energy is released. Okay. When the new bonds are formed, then the energy is released. Okay. Are you getting my point? When this is a two hydrogen atom, you have to separate them. You have to pay some energy. Okay. So this is endothermic process that you are breaking the bond. This is endothermic process. Okay. You are breaking the bond. And when new bonds are formed, then energy is released. It is like a business. Like, for example, you are investing some money in a business. It is your investment. And if you are getting more money from that amount the amount that you have invested, you are getting more profit. You are getting more money. So that you will be in the profit. For example, you buy something for 15 rupees and you sell it for 20. That it means that the amount you use there is more than the amount you gain. Cost price is more than the selling price. Sorry, selling price is more than the cost price. So it will be profit. Same thing happens here also. When when the elements are reacting together, so first their original bonds are broken, and then new bonds are formed. So if the energy supplied for breaking the bond is less than the energy released during the formation of new bonds, then this type of reaction is known as exothermic reaction. Here we write here the reaction in which energy supplied is less than the energy released. Means we are supplying less energy to break the bond, but large amount of energy is released after the formation of new bond. So we will say that this type of reaction is known as exothermic reaction. This is another definition. Note it down. Note it down, please. The reaction in which energy supplied is less than the energy released is known as exothermic reaction. You done this one?
Yes, sir.
Now, in terms of chemistry, we use a word enthalpy. Enthalpy. Now, in the chemistry, we just require a system. We have two things: surrounding and the system. We have two things. One is surrounding, and another one is system. The reaction in which the area or the things in which the reaction, or we can say that the area which is in our observation is considered to be a system, and the area surrounded it is known as surrounding. For example, if you are doing an experiment and taken hydrochloric acid in test tubes. Okay, just a minute. Just a minute. So, please come. Here I'm saying that, for example, this is a test tube. In this, the reaction is taking place. Okay. So this will be considered as system. And the area around it will be considered to be a surrounding. This area will be considered as surrounding. This is surrounding. Surrounding. Okay. So in the exothermic reaction, the heat is released. Heat is released, so it will be going from system to surrounding. Heat is going from system to surrounding. Heat is going from system to surrounding. So when the heat is going from system to surrounding, since the system's energy decreases, the energy of the system decreases. So we will say that enthalpy change for this reaction is negative. Okay. Enthalpy change for this exothermic reaction is negative. Okay, note it down. For exothermic reaction, enthalpy change delta H is negative. Is negative. Noted. For
Yes, sir.
exothermic reactions are called spontaneous reactions. We called it spontaneous reaction. Why? Why we called it spontaneous reaction?
Continuous.
Yeah, because spontaneous means if the exothermic reactions starts, these are spontaneous reactions because they require one-time initiation energy. For example, if you start burning a all the coal will means keep on burning. It will not require energy, but you need to ignite the first coal, and then it will keep on burning. You keep on adding the coal. It will keep on burning until the whole coal will finished. Okay. So we'll say that if you if you start burning a magnesium ribbon, it will keep on burning. Okay, unless and until whole magnesium ribbon is got empty. Okay, so we'll say that this type of reaction is known as spontaneous. Spontaneous means they keep on going. They require only one time initiation energy and they keep on burning. So please note down the example of, like, for example, of an exothermic reaction is magnesium oxide burn. It gives you heat and light, carbon, water, burning of water. And this is very popular that when you add this is slag lime. Sorry, quick lime. Calcium oxide is quick lime. Quick lime. When you add it, it will gives you slag lime. Slag lime. And this is known as slaking of lime. Note it down. The popular exothermic reaction used in whitewashing. It is also used in whitewashing. Okay, note it down. Then we're going to study in the next class displacement and double displacement reaction. So note it down. All displacement and double displacement reactions are exothermic in nature. All displacement and double displacement reactions are exothermic in nature.